Hello everyone, welcome back to my channel. My name is M. Ganeshmani, USN 1BE 22EC 056, pursuing my BE at Sri Venkateswara College of Engineering in ECE stream. So the course name for today's video is Principles of Communication System and the course code is BEC 403. So the topics that we are going to be looking into today's video is pulse amplitude modulation and frequency division multiplexing, which is also known as PAM and FDM. Now first, let us understand what do you mean by PAM, which means pulse amplitude modulation. So pulse amplitude modulation, it is an analog pulse modulation scheme in which the amplitude of the train of the rectangle carrier pulse are varied in accordance with the sample value of the modulating signal. In PAM, the top of each modulated rectangular pulse is maintained flat. So PAM is same as flat top sampling. So we can understand by this video that pulse amplitude modulation is an analog signal and it is same as flat top sampling. As well as we can also understand that the rectangular carrier waves are only used in this. And next we'll be getting into the waveforms. From this image we can understand that there are the waveforms where there is message signal and terrain of impulse and sampling signal and terrain of pulse and later the PAM output pulse amplitude modulation. So in this we can see the difference that the pulses are amplified and the amplitude is varied. So this is how the modulation occurs and this is called pulse amplitude modulation. Now let us understand what are the advantages and disadvantages of PAM. It is a base for all the digital modularization signal. Disadvantages of PAM: due to the Nyquist criteria, it requires high bandwidth for transmission. Since the amplitude keeps varying, so there is noise accordions with it. Detection of PAM signal. The original message signal M of t is obtained and the PAM signal to the reconstruction filter is followed. As we can see in the diagram that PAM signal S of t is going through the reconstruction filter and then to the equalizer and then we obtain the message signal. This is how the detection of pulse amplitude modulation takes place. So this is the graph of the pulse amplitude modulation. As we can see that the pulse amplitude modulation varies accordance with the sinusoidal wave as well as the rectangle pulse. So we can see that the variation in each pulse is occurred when these two message signal as well as the carrier signal is combined and we obtain the pulse amplitude modulated signal in the fourth diagram. As we can see that each pulse varies in their amplitude in respective position. That is how the amplitude varies and the modulation occurs. So this is how the signal is passed or the signal is detected. Now let us understand about FDM, that is frequency division multiplexing. So the multiplexing is divided into two categories, that is the transmitter and the receiver. So this is the block diagram of transmitter of FDM system where we can see that there are two signals, signal 1, signal 2 and inputs up to M kind of inputs. Starting from signal 1 is the input 1, signal 2 is the input 2, signal 3 is the input 3 and up to M number of inputs can be taken place and they are sent into a individual modulator from where the carrier frequency is generated respectively, which is carrier frequency 1, 2, 3 and up to carrier frequency n. So till here we can obtain all the carrier frequency. And what does this multiplexer does? All the carrier frequency are passed into a linear mixer or a summer which converts this all carrier signals into one single cable. That we also we can see in this slide that all carriers are combined into single compiled signal that modulates and transmits, and then it is transferred to the single communication channel and it is received through the antenna and it is transmitted to the other antenna respectively. So this is how the block diagram looks for a transmitter in a frequency division multiplexer. So this is also the block diagram. As we can see, we can clearly see over here the block diagram, as there are n number of modulators and n number of channel, and they are converted into a single channel while they are passing through the linear mixer or adder. So this is how the transmission process takes place. So this is one of the examples that we can give for transmitters. Now let us understand properly about the frequency division multiplexing in transmitter form. So each signal to be transmitted and feedback a modulator circuit. The carrier for each modulation FC is on the different frequency. The carrier frequency are usually spaced from the another over the specific frequency range. Their carrier are refined and subcarriers. Each input signals is given to a port ion, and between its illustrate is the figure B. So from figure B we can see that this is the signal how it, or the waveform which is obtained by transmitting the signal. So in between that we can see that between of an overall communication channel we can see the frequency is divided, and the bandwidth of single channel is also observed in this diagram. We'll be looking into it clearly in the next upcoming. So now let us look into the receiver of demultiplexer. The receiving portion of FDM is the vice versa of module transmitter process, in which first the signal is received from the antenna, then it is passed to the RX, which is the linear mixer or the single communication channel, from where the single communication channel is refined, and then it is sent to the demodulator. From the demodulator we can observe that the signal is passed and it is divided into variety of signals. That is, it from one signal it is converted into many signals. In transmitter we used to convert various signals into one single channel. Here from one single channel we converting into various channels. The signal received is demodulated into the composite signals, so which is passed to further by BPF and then to the demodulator in order to obtain the original signals. So this is how the receiver demultiplexer works. This is how the block diagram looks for a receiving demultiplexer, from which we can see that a common channel is divided into various channels, and that is passed through BPF 1, 2, 3, 4 up to n in order to obtain the individual channel selected by BPF, and then it is sent to the demodulator in order to obtain that original signal. So this is how the block diagram looks. So now let us look into the key points of FDM. Any of the standard kind of modulation can be used in AM, SSB, FM, PM, or any various digital modulation methods. The FDM process divides up the bandwidth of the single channel into smaller equally spaced channels, each capable of carrying information in sidebands. The output modulator has the sideband information. It adds on the linear mixer, no modulator or generator of sideband taken place. The resulting output signal is composite of all the modulated subcarriers. This signal can be used in modulation of radio, that is TX image. So here we can see that this is how the signal is flowing, where we can see that the frequency division is taken place, and each amplitude where the division between each signal is done by FC1, FC2 up to Fn. The bandwidth of single channel is observed, as well as the bandwidth of the overall common channel is also observed. So this is how the waveform is obtained. This composite signal sent to the group of BPF, each centered on one of the carrier frequency. Each filter powers only the channel and rejects the others. The channel of demodulating and then recovers the original signal of the input signal. So this is how the FDM in receiver works, and these are some of the key points that we have learned. And now we'll be looking into the application, that is telecommunication and FM spectro broadcasting. So these are the two kinds of FDM applications, and we can use in further kind of telecommunication as well as broadcasting nowadays. Like we are using in telecommunication like Jio or Airtel. Every company use the FDM only in order to obtain a precise input as well as output. So this is one of the major application in today's real-time industry. Thanks for watching this video. Please do like, share and subscribe to my channel. Hit the bell icon for latest notification. Stay tuned for more upcoming videos. Goodbye.